Good evening. I am an educator from Kepler Educations, and this is the 12th video of our POTD series. So, yesterday my health condition was extremely bad, and I was really sick yesterday. That was the reason I wasn't able to cover yesterday's problem. Due to my extremely poor health, it was impossible for me to get up and record yesterday's video. However, I believe that today my condition improved a bit, and that's why I am able to record today's video. So, before starting off with the video, let us first remind our viewers of our targets. That is 500 plus views, 150 likes, and more than 100 subscriptions. So please help us in achieving that. And also, if you are wishing to study systematic and low cost placement preparation series, then please join our course. It will be an ideal place for you to increase or enhance your skills that are required in today's job market. So without wasting any more time, let us start with our video. So today's POTD is swap Kate nodes from ends. So it is a very simple question of linked list, and this is a very simple question of linked list firstly, and secondly is that I believe this week of GFG it is going to be dedicated for linked lists. So it is a very simple question. What is it given? It is given that we are provided with the head of a single linked list and an integer k. We have to swap the Kate node. The Kate node is based upon the one based indexing. So you have to use one based indexing in this particular linked list. So you have to swap the kth node from the beginning and the kth node from the end of the linked list. Kth node from the end means n minus k plus 1 is node from the beginning. Even it is one based indexing or zero based indexing, it doesn't matter. It is one based. The kth node from the beginning end will always mean n minus k plus 1 node from the beginning. So we have to return the head of the final linked list formed, and if it is not possible to swap the nodes, we have to return the original linked list. Let us go to today's problem. Yes. So let us say the linked list is this particular linked list. This is the linked list. This is the head as given here. This is the first node. Okay, I will come to the first node slowly, not right now. And this is the second node. And this is the tail node. Okay, the second node. I'm sorry, I shouldn't have said the second node. It's the tail node. So let us say k is equals to. So you have to find out the second node from the beginning. Now, what is the second node from the beginning? This is the second node from the beginning. So we will name it as first. And we have to find out the second last node from the end. What is the second last node from the end? This happens to be the second last node from the end. So we will call it second. So what we have to do, we have to simply swap these values. So swap first arrow data, second arrow data. So we will do very simple thing. We will do swap first arrow data in CPP, first dot data in Java, second arrow data. Now this swap function will work in order of one time because it is simply swapping these two particular guys. And the final linked list that is formed thus becomes 1. This becomes 4. So the 4 comes here actually. The 4 comes here and the 2 goes here. So at the end the linked list becomes 1, 4, then it goes to 3, then it goes to 2, then it goes to 5, and then null. So this is the head, and this particular head you have to return. So before starting this particular problem, let us observe some things. This is the linked list. Very well. So what does it say? K. Let's say k equals 2. Okay, one more thing. When is k not possible? So when is k not possible, you have to find out. So if let's say if k is equals 9, then what is the ninth node from the first? There is nothing ninth node. So in this situation, you will simply return that. So let's observe something. If k is equals 2, it is 1, it is 2, it is 3, it is 4, it is 5. So the total length of this linked list is 5. This is something that you have to find out. So if this length is of 5 length and this is the second last node from the end, then what is 4? 4 equals 5 minus 2 plus 1. So using this observation, you can say kth node from start n minus k plus 1th node from start. These two you have to swap. The first thing that you will do is that you will simply find out the length of this particular linked list. You have to find out the length of this particular linked list because you do not know the length of this particular linked list. So we will keep a pointer. We will keep a pointer by the name of this the head. We will keep a pointer ptr equals head, and we will move the pointer. We will keep a counter equals 0. So when it is at head, it will do increment it with 1. Then the pointer will go here. It will increment it by 2. Then the pointer will go here. First step increment it by 3. Second step move the pointer to here. First step increment the counter to 4. Move the pointer to here. First step move to increment the counter to 5. Move the pointer to here. Pointer becomes null. You have to stop the iterations. So you will first keep in n equals 0 while ptr. Then what you will do? First you will increment the counter. Then you will move the pointer. ptr equals ptr arrow next. Simple. This gives you in order of n time. I'll go to the later. Now you know the n is calculated. Length of linked list has been calculated. Now you have to find out the nth and the n minus k plus 1th node. Let us say int. You will just go one by one. You know the length is 5. Basically n equals 5. Therefore and k equals 2. So you have to find out the second and 5 minus 2 plus 1. That is 4th node. So you will put a counter as 0. This is ptr. What we will do first, increment a counter by 1. Get the move. Okay, sorry. Yes. First increment a counter by 1. Move the pointer to the next node. Then increment a counter by 2. You see the counter becomes 2. You see the counter becomes 2. You see the counter becomes 2. This you mark this as first. And then move the pointer to the next. You first increment a counter, then move the pointer to the next. First you increment a counter. You see that the fourth is coming here. This I forgot to mark. You see that the fourth has come here. You have found a fourth. You have found a fourth. You have found a fourth. So mark this as second. And then move the pointer to the next. First increment a pointer, then move the pointer out of the range. So this will be the algorithm. Let me code down the algorithm. So first is node star first. You will put it as null first. Node star second. You will put it as null then, and you will put a counter cnt equals 0. Okay, also you will use the same pointer as before and you will mark it as head while ptr. First you will increment the counter. Then you see if cnt equals what was the first thing? K. Then what will you do? You will say first equals ptr. But if it is not k, but it is the second node, else if cnt equals n minus k plus 1, then what will you do? Second equals ptr. Done. And then you will move the pointer to the next node. This is the overall algorithm. Now, if your second does not exist, for example, if the if k is equals if k equals let's say 20, in this situation you will never find you have move pointer, move pointer out of bounds. You see when pointer goes out of bounds, your cnt value becomes 5, and but the first is still empty and the second still remains empty. So if second is empty, null, then k is greater than n. This is for sure. You can also put a pointer above it if k is greater than n, then return head. Your choice. If not of second, return head. Now you will do the main thing. You've got the first and second pointer. You will swipe their values. First arrow data, second arrow data, and then what you will do? You will return head. Your swiping has been done. This is the overall function. This is a continuation of the earlier function, so there is no need to give brackets here. So before starting up with going to the time and space complexity, let me first show you the code. So this is the very simple code. You will first you will have a counter cnt. The first node is initialized as null, the second node is initialized as null, the ptr is initialized as head, and the length of the linked list is initialized as 0. First you will find out the length of the linked list. So while ptr, first you will increment the length, then you will move pointer to the next one. At the end, when pointer goes out of bounds, then you have calculated your n length. If after the fifth node the pointer goes out of length, then the count of n will be 5, which is the length of the linked list. Now you will do a reiteration of the entire thing. So you will put pointer as head again. So while ptr, you will first increment the count. Now if you see that you have found out the kth node from the beginning by using one best indexing, why I have made counter plus plus at the beginning? To ensure that I do one best indexing. If I made counter after this, Like after ptr equal to ptr next, after this if I had done cnt plus plus, then I would have done zero best indexing. But here incrementing the counter plus plus, I'm doing one best indexing. So if it is equal to k, this is the first node, and if it is equal to n minus k plus 1, which is k node from the end, it is the second node. So next you will move the pointer. So as I said, if k is greater than n, or if not of second, both will result in the same ideal condition. Exactly the same condition they will both return to. You will swap, you will return head. There is no point in swapping anything. Else, if you do not put this condition, then you will get an unpointed exception in this particular part, because second does not exist and first does not exist. They are null pointers. So you have to put this check. Then you will have to swap the first until second nodes, and then you will return head. Let me put the code in here. Now I will move to time and space complexities. So you see from here, from this particular thing, okay, so these all are O((1) operations. This while this particular thing will take order of n time. Also again this particular reiteration will take order of n time. These are the O((1) conditions. So what will be the total time complexity? Order of n plus order of n. Your time complexity will become order of 2n. What will be your space complexity? Order of 1. If you're not, if you're assuming that if you are not considering the space that a linked list itself is taking. Okay, so this was all for today's problem. Okay, I should run and submit it once. Yeah, it ran perfectly. Let me submit it. Yes, it got submitted perfectly. So as before, this entire notebook shall be available on our website, kepler22b.vercel.app, in the resources section of our library, in the community library. The flow is actually library to resources section, then to the community library. This is the flow actually. I guess I wrote it in a different manner, whatever. So this was all for today's problem. Please come to our website and check out our courses. It will help you out, that I can promise. Also, our prices are very low, and one problem about the free sources on YouTube is that the structuring, the sources are quality sources, that no one doubts, but the thing is they are not structured, most of them. So one thing that you will get in Kepler educations is that you will get the proper structure and guidance without applying your without wasting much time in thinking about how you should study, because we will tell it to you the optimal way. Another thing is that in we will provide with resources, materials, will provide you with guidance that are better than the free sources. So if you are sincere about your future, if you are serious enough about your future, I would recommend giving Kepler a try. So the rest is up to you, and this was all for today's video. I hope to see you in the next one. Thank you.